when it's a small gap, because let's see, sometimes when you're printing stuff, if the gap's small like that, I have my support material turned off so it can actually bridge that gap, and I just thought I'd film it just to show you. This is for Ken actually, I'm doing this for Ken because just so he can, he's having trouble with his printer at the moment, and I just wanted to show him that normally the printer can bridge a gap like that. But I think my nozzle is a bit clogged up at the moment because it just bridged the gaps, but it's left some holes. But it should be able to sort it out on the next run. The next time it goes over there, I'll try and set the stand up. Actually, just give me a sec, I'll set my camera stand up. Oh yeah, my magnets arrived, by the way. My magnets arrived today, early, and I'm really glad. So I've actually got them in the, I've actually put the magnets in the new stator. So this is the new stator, but I've got 3 in each slot. I'm actually going to put 3 in each slot on the other one as well, which is still in the device across the room. So we're going to increase the magnetic field on it. Just let me I'll just try and get this cover off the back of the phone so I can put the phone in the camera stand. Yeah, I've been sorting out the rotor, getting it dead true as well. Let's see. Get this in here without breaking my camera stand again. I want to lower the legs a bit. So it's about to fill them holes. So I'll film that if I can get it there in time. By the time I finish faffing it, will have filled them up. So, right, so the holes. Oh, this whipping thing's too tight. Right, so if we can zoom in without buggering this up, you'll see how it can bridge that gap. Stupid thing. Turn. The light's a bit too high. So that is printing over a gap of about 10mm without any support material. You can't go much more than that. I mean, the hole underneath is, there's nothing underneath there supporting that. So after this layer, subsequent layers that come on top will be much more flat. Now let me just put the my lamp on the floor. Hang on a minute. Oh bollocks, I'm dropping everything. Just a minute. What is wrong with this stupid phone? I mean this stupid stand, turn. Right, there we go. So I was trying to give you a bit of a close-up. Let's see if I can get a bit higher. So, as you can see, I'll pinch it over those gaps, no problem. And there's absolutely no support material in there. The light's in the way now, so there's no support material in that hole. As you can see. Anyway, just a quick video really. He's having trouble with his steppers on the Z-axis, which is the vertical up and down, and I had this problem myself, but I just reduced the throttle speed, the Z-axis right, so I'm going to turn that off. I mind my light. No. Just put the light back over here. We don't want to watch hours and hours of video of 3D printers. Let me just zoom back out. Right, so let me get my phone out of here. Right, sorry about that, hang on a minute. So right now I'm printing the stands, obviously, as you saw. So I'm going to have two stands side by side. So there's that stand, and then we use the other stand on the wider assembly when I put it together. I've got wiring coils on the new canopies, which are I've got them in here. So this is the new wider canopy to wind the coil on. It's I'm drying it slowly in this airtight chamber because the acetone dries out, and it doesn't, very slow, and it doesn't warp, otherwise it curls a bit. So by putting it inside the chamber and letting the air in every now and then, it doesn't curl up at the edges. When you put it in a drafty area, it has got a bit of a curl there, but I'll sort that out later. I'll just heat it up with a hairdryer. I've got to put the contact tape on these, copper contact tape on these, but by drying it slowly, it makes sure it doesn't curl really badly. If the actual structural main frame part, that is the main area, which is going to be adjacent to the rotor assembly, like so, if that was curled too badly, it would come in contact with the drum, the rotor drum, and we don't want that. So I've got to make sure it doesn't, because there's going to be two rotors in there, side by side, back to back. So I've got another half down here, another canopy. I've got to print the other half of this. This has been acetoned and it's all shiny, and yeah. So yeah, just a little update on what's going on right now. So I'm going to be winding a coil probably tomorrow, I don't know. I'm going to be using 30 SWG because I want to get more current out of this thing, because I don't want to be messing about with 12, 13, 14 milliamps. It's ridiculous. I mean, I need a lot more than that. So I need to get the voltage up as well. So so I just thought I'd let you know what's going on right now. At least I got the magnets, and I've got the stator part done, and oh, a little update on my robot vacuum. The robot vacuum is still not right. I suspect well, he's in the kitchen right now, so I'm not going to bring it back in here right now, but I'm not using him right now because there's still a gear slipping. It only happens when he's up against the skirting board for some reason. I'm not sure why, but whenever he's up against the skirting board, the edge of the room, he seems to get stuck again. And I think that the gear is still slipping, so some of them gears are probably worn down a bit. But what I'm going to do when I get around to it is I'm going to take that gear assembly back out, and the next time I'm going to remove all the grease so I can see what's going on properly, because I couldn't see properly with all the grease. And I'm going to examine all the holes to make sure the holes aren't egg-shaped, you know, one out on one end and, you know, egg-shaped basically. And if any holes are egg-shaped, I'm going to line every single one of them. And that's the only thing I can think of to do right now, because otherwise I'd have to order new gears, and that's going to cost me an arm and a leg. I'm pretty sure it will. As I say, I don't want to spend a load of money on this robot vacuum. I mean, it was, when I bought it new, it was about 80 quid. It's not worth it. To get another gearbox and everything, I don't think it's worthwhile getting another gearbox for it. I mean, it's just be better off saving up money and buying a better quality one, you know, something that's not going to wear out so quick. I mean, well, I've had it since 2017, and it's done pretty well considering it's lasted. You see, the other thing I don't really like about the robot vacuum is it tends to churn up a lot more dust. I mean, the brushes tend to churn up more dust than he sucks up, right? Because that's why my tables, everything's dusty. I have got electrostatic air cleaners down here, which needs cleaning as well, because the filter down here, it's ready for cleaning. It's electrostatic and it sucks all the dust, and you can see it's all stuck to it. That attracts loads of dust because it's high voltage in there, and it attracts the dust to it, and there's a fan sucking air through, and it filters the air, and that's the reason why there's so much crap and dust in this corner, because of the electrostatic air filter. And I cleaned my printer yesterday because it was covered in dust, and it's really bad. And this is supposed to reduce the dust, not add to it, but because it's electrostatic, everything is attracted to it. So I get dust all over my fire, right? It gets really bad, and I keep dusting. But the robot vacuum, every time he's out and about cleaning, his little brushes, he can't suck everything up. He only sucks up so much. He does do a good job, but he tends to churn up a lot of dust, and it gets all over my hi-fi. I don't even use my record player right now, but look at my record player. Look at the state of that. Yeah, I mean, dust gets everywhere. And the main reason I've got a big dust problem is because of the sandpapering and all the hobbies I'm doing. You know, working on plastic, you tend to get a lot of plastic dust. It's not just plastic dust though, it's obviously just being in here and working in here, and yeah, basically living in this place. And not, when you're in lockdown you can't go anywhere, so you make more dust anyway. So, but I haven't got around to fixing my VCR, which is down there in the cupboard. The audio went on it last week, was it 2 weeks ago? The audio died on my VCR, and I haven't got around to fixing that. That's going to be, yeah, I don't know when I'm going to get to that. I really don't. I want to get this generator thing built first. I want to see how I'll go with that, and then I'll think about the VCR. But it's not urgent, because as I say, I've got a backup VCR. My Panasonic VCR is in there, but I've still got the Grundig, which is this one here. So I can still play video, so that's not urgent really. It's not urgent. But number 1 on the list sort of thing. It's number 10 probably. Number 10 on the list of all the other things I need to do. What else is there? I think that's it for now, update wise. Yeah, as I say, I've been truing up the rotor to get it so that it's not wobbling when I'm spinning it. Hard to show you really, but I haven't got the bearing set right now, but it's hard to show you on here. I did have it on my old generator to check the balance. This thing here, I started it up earlier. Oh, I can show you what I mean. Hang on, just a second. Just give me a minute, I'll try and do it and show you what I mean. So, oh, shit, what did I just do? Back. Oh, I went and knocked a menu. So what I've been doing is sticking the rotor on my old generator like this and screwing it up to get it so that it's running straight. Hang on, see if I can get it on here. There we go, I've got it on. And turn my power on. Oh, it's still on actually. Then I'm trying to get this, just a minute. I have to get it started. I'm going to put the power on to the my drive circuit, which is MOSFET pulse driven. So connect my pulse drive. Come on, bloody clip! I can't do this with one hand. Connect my pulse drive like this, and get my drill. Start. I'm not using the output, obviously. I'm just using this as a motor right now to spin that thing up. So. Start my pulse drive with this little drill. Come on. You see the light splashing over there in a minute. There we go. So now it's running under its own power. The LED's flashing. As you can see there. So my homemade circuit which I drive, that drives the MOSFET which drives this circuit board here, which is all covered in dust as well. Oh, it's not going fast enough yet. Not enough power, it's the blue light's going out. Not enough power, but there is a tiny amount of wobble on it, not much. That's because of warpage on the sections, because it's in 3 sections. There's a bit of warpage on there, but right, I didn't get it fast enough. The voltage was too low. Let me just start this thing again. Let me just start this thing again. Come on. That should be going now. Turn that off. Let's check the voltage on here. Well, I've got power. Turn that on. And that's drawing 190 milliamps. It actually uses very little power, this thing. So 190 milliamps at 13 volts is pretty good. This thing gets up to... So the pulse drive is spinning my rotor, just so you can see how true it is. It's pretty good actually. I'm trying to keep my hand still, just a minute. You can see it's true, it's good. The gyroscopic effect of when a disc is spinning automatically will straighten out any tiny irregularities in the azimuth of the disc or the rotor. So if you've got a slight tilt, very slight, obviously you don't want too much of a tilt, otherwise it's going to really cavitate. The word cavitate is wrong. Don't know why I keep using that frigging word, it's the wrong word. But it will cause, if it's doing that too much, it can cause a lot of strange things, like things dancing around on the table. Even though the rotor's actually balanced, it can cause twisting effects. But anyway, I left it running. I super glued the inside of the plastic tube, where the drive shaft goes through. Then I stuck it on the drive shaft, glued it to the shaft, then I spun it like this at about I haven't got the RPM meter hooked up on here right now, it's hooked up on that other thing over there, so I'm not really worried. It's running. I'm only running it pretty slow actually. So this thing's spinning and the gyroscopic effect straightens it out, and then I just wait for the glue to harden, and when I took it off it's nice and true and straight. And this actually uses less power. The than my little tiny motor that I was using over there to drive that thing. So it's actually pretty efficient power wise. Oh, computer's gone to sleep again. Wake up. So yeah, I've been doing that all day to get this thing trued up. That's all really. So Captain Kirk would say warp factor 2, but no, I'm not going to go that fast right now. So yeah, I'm just going to turn the power off because it's trued up already now. Just thought I'd show you what I was doing earlier. So I'll turn the power off and put that back. I haven't changed any of these potentiometer settings. They're still set the same way, so we can have an accurate comparison when we do that with the two dual rotors. The only thing I did turn was the voltage range was 0 to 10 or 10 to 20, so I could get a high voltage to run this thing here. But since the current's about the same, I didn't need to adjust anything else. But you'll see that'll go out in a sec. It's running on supercapacitors right now. Yeah, it's starting to dial up. The yellow current limiting thing's coming on. It'll go out in a sec and it'll come to a stop. So using my old, well, it's not really old, I only built it a year or two ago, didn't I? Was it a year and a half ago? Was it? I can't remember now. I think it was last summer. But it's good for helping me to get my rotor trued up. Can't keep my hand still. It's definitely nice and true anyway. I always like to test things on here before I actually put them on the other unit. And also notice the segments aren't working the way out, they've stayed in there, which is good. So the lights are flashing and the blue light's going to go out, stop blinking in a minute, because that's the pulse drive. You can see the strobing effect is slowly slowing down. It's going to go out in a sec because it's running out of juice. There we go. Now it's no longer being powered. Blue light's not running, so it'll just come to a stop now. So as I said, there's a touch of wobble, but I'm not worried about that because it straightens itself out once it's going. Right, okay, that's just everything that's going on right now.